Hello everyone. Today I'm going to start a new course which is Design and Analysis of Algorithms. This subject is having 5 units according to Computer Science and Engineering students of OU. Now we'll be going to have clear, simple explanation of each unit topic wise. Now, Unit 1, Topic 1 is Fundamentals of Algorithm. Now, what is an algorithm? Algorithm is a step-by-step procedure to solve a computational problem. Whatever we are doing, that will be a step-by-step process. Let's see if I wanted to add two numbers. Now I wanted to add 10 plus 20 and it is a computational problem. So when it is a computational problem, I cannot write this result directly, which is 30, right? I have to take this value, it is the first step. Second, I have to take this value, and third, I have to put together. All these are step-by-step procedure. There are some properties which help user to write an algorithm. Those are input, output, definiteness, finiteness, effectiveness. Every algorithm should be given 0 or more input. If you wanted to display hello world message, probably will not give any input. So that is what 0 input. More input means you can give as many as variables or values as your inputs. Output is what? At least one quantity is produced from the algorithm. Definiteness. Each instruction should be clear and unambiguous. Unambiguous is what? No duplicate. You cannot write in the algorithm the step which is already there in the algorithm. That is what? Unambiguous. Finiteness. Every instruction should have finite number of steps. If I am performing some operation, it should have finite number of steps. Effectiveness. Effectiveness is what? That we have to write effective code. It should get carried out into your computer to code it properly. These are what properties. And there are 3 terms where we feel or something that is there having any difference or they are same. So those 3 terms are algorithm, pseudocode, program. I'll give a simple difference among all this. Algorithm is what? It is a step-by-step procedure. Pseudocode also step-by-step procedure. Program also step-by-step procedure. But the difference is algorithm is a formal notation. Pseudocode is what? Informal notation. Program is what? Using some language. Program is its collection of instructions which you can make ready to execute. Now, algorithm, pseudocode or seems to be very same, but as I told you, algorithm is formal way of writing, pseudocode is informal way of writing. You can find some examples on the screen, and here we wrote something like this and something like this. The logic is same, but the way of writing the algorithm is little bit different. So the intention of writing this algorithm to find out the biggest of 3 numbers, and you can go ahead to write something like this. And the major difference in between program and algorithm, we will not tell the data type of this ABC. It is not required in the algorithm, because algorithm will not talk about to which data type they belongs. Something this that are very simple to know what they are performing. You can also see some of the examples. Even these are called as algorithm. In the previous slide, you might have seen step-by-step process, and here I did not mention the step number. Though I mentioned or not mentioned, algorithm can be written any of the way, because there is no proper rule to follow in the writing of algorithm. And when you find some algorithm, it is also user job to know whether the algorithm is best or not. This best word is knowing about the ability of algorithm. So when I wanted to know the ability, performance, there should be some measure to analyze the performance of an algorithm. That is, there are two factors to measure the performance of an algorithm, which is time complexity and space complexity. Okay, this thing will be seen in the next slide or next topic clearly, but we'll continue to talk about how to calculate the complexities for an algorithm, especially time and space. So there are two methods to do it, which are line count, operation count. So according to the CSE syllabus of Unit 1, the first topic is this, and that's what you might have seen the same name in the first slide. So that is what line count and operation count. These two are the methods through which we will calculate time complexity. Time complexity, we'll use frequency count or step count and operation count. And we'll see what exactly these are. I took some example for the better understanding. So this example is what I wanted to find out the maximum element from the array. This is what computational problem. Now for this computational problem, I took some steps to solve. So this is what the algorithm. Now, when you look at all these instructions, all the instructions to execute in the computer, they required some amount of space, they required some amount of time. And space complexity is what? The amount of space which is required to store these instructions. Time complexity is what? The amount of time which is required to execute these instructions. Now, let's see using of this algorithm how we can find space complexity and time complexity. Now, when you look at all these instructions, your focus should be to find out the basic operation. What is the basic operation? In other sense, I can tell basic operation is nothing but the instruction which takes maximum time. Instruction which consume maximum time. When you look at this, the first line will get executed for single unit of time and everything is the same, but this operation is basic operation because it consumes maximum time. So how many basic operations we found? Only one basic operation. And this basic operation is what? Comparison operation. We are comparing it. So I am denoting basic operation B is equal to 1. Now, what is the line count? Line count is what? Basic operation times of execution. How many times this basic operation will get executed? As the for loop has begun with 1, it end with less than n. Less than n in the sense what? N minus 1. Now the line count is what? C of n is equal to n minus 1. Now the time complexity of this algorithm is the product of basic operation and line count against to the n. So that is what and the complexity of this is what? Product of basic operation, right? What is the time complexity? 1 into n minus 1. So maximum will ignore the constants, correct? We'll ignore the constants and we'll consider this n. So finally, the time complexity of this is big O of n. So this big O is a notation to use to represent time complexity. That also will come to know in the next topics. So for this, I am explaining you just a symbol I'll tell you in the next videos what is this big O. Now, the next is about frequency count method. Frequency count method is what? In order to calculate time complexity, we use frequency count or step count, and it specifies the number of times a statement to be executed. So rules to calculate frequency count, for comments and declarations the step count is 0. For written and assignment statement step count is 1. The very most important point is this. You have to consider higher order exponentials only. Example, 2x power 4 plus 4x cube plus 5x square. Now ignore this constants, ignore that 2, 4, 5, and what is this? X power 4, x cube, x square. So according to this rule, now higher order exponentials only considered. So we'll ignore these two. So finally it is what? X power 4. So step count of above statement is 4. So in written we will write big O of n power 4. We'll take the other example also to see the space complexity and the step count of the algorithm. So this is the algorithm. In the previous slide, we saw the rules to find out the complexity. So for variables, its step count is 1. And for this loop, the step count is n plus 1. And the step count is n. Step count is 1. So here the step count is n. Why? Till this condition, till I value reaches to n, it will get repeats. So the step count of this statement is n. And written statement for s equal to 0, for these two statements step count is 1. Finally, total frequency count is what? 1 plus this 1, n plus 1, this n plus 1, n, 1, 1. 1 plus n plus 1 plus n plus 1. Total 2n plus 3 is the complexity of this algorithm. And so finally we wrote step count is big O of n. Why? Because higher order priority. So this will be written as 2n power 1, 3n power 0. Okay. Now finally n power 1 is higher order, hence step count is big O of n. Now the space complexity is array contains n elements, correct? Array contains n elements. Now array contains n elements is n spaces we required to store n. Now the next is what? N is 1, s is 1, I is 1. Finally s of n is equal to, s of n is what? Space complexity for n, that is n plus 3. This n plus 3 is came from c plus sp. This c is what? Fixed part of the variables. sp is what? Variable part of the variables. In the algorithm. Generally, in the algorithm, we will be finding out variable part and fixed part. Variable part in the sense this n, fixed part in the sense this. Okay, n, s, I are fixed part. So finally this is what? 3, and n is what? Variable part. Other example, in this example, to execute this we need n plus 1. To execute this we need n into n plus 1 because it is available inside of this loop. And this execute for n times. So finally it is big O of n square, n plus 1. You can write here n plus 1. To execute the first step n plus 1. And the next step n into n plus 1. And the next step n. So when you consider all this, you will get n square plus 3n plus 1. Finally, higher order priority, which is n square. So the space complexity is also n square. So this is about the first topic. Thank you all.